Assalamualaikum. We are from Group 5. It's Nur Akila Medical. The first one is process description. The selected process for benzene production is hydrodealkylation of toluene H2A. Toluene and hydrogen are converted in a reactor packed with chromium or molybdenum oxide catalyst to produce benzene and methane. The reaction coefficient is at 90%, while the reaction is highly isotonic and irreversible. It's a piping and instrumentation diagram. As you can see, this is a PNI diagram of benzene production. PID controller is an instrument used in industrial control applications to regulate temperature, flow, pressure, level, speed, and other processes. The basic process control system is responsible for the proper operation of the plant, and in many instances is used in the first layer of protection against unsafe conditions. This system can be designed for particular performance and economic improvements, such as reduce variability to produce more consistent and quality product, increase efficiency that can lower operational costs and increase production, to improve safety, and also to improve troubleshooting and system diagnostic. As you can see from the PID diagram, the blue box represents level control loop, which used to control the liquid level in process tank. The red box is a temperature control loop, which functions to control the temperature of certain equipment from overheating. The last one is a yellow box, which represents a pressure control loop that used to control the pressure and to prevent from any explosion of fire occur during the production. Is a possible hazard may occur during the benzene production. The first one is chemical hazard. Long exposure time to the volatile toxicants in the benzene production can affect the health of workers through ingestion, inhalation, eye contact, and also skin contact. Improper way handling, such as not wearing proper PPE, can increase the exposure to the chemicals. Benzene is known as a highly flammable liquid and vapor that distance, ignition, and flashback. Ethane is a chemical that can cause headache, nausea, and vomiting. Electrical hazard. Electrical hazard may occur when there is improper wiring in the plant. Damaged electrical parts also can lead to a fire in the plant. The third one is biology hazard. Microbiological hazards include bacteria, yeast, mold, and virus. Exposure to dangerous substances and disease associated with working amongst animals, people, or infectious plant materials. Dust particles can also be present during the production if the plant's housekeeping is poor. Next is mechanical hazard. Mechanical hazards are hazards created by the use of or exposure to power or manually operated equipment, machinery, and plant. Mechanical injuries are most likely to occur caused by either contact or entanglement with machinery. Heavy and overload of equipment can cause rupture or damage to pipelines and instrumental failures. Ergonomic hazards are known as a risk factor in a work or other environment that could cause damage to the human skeletal system. Frequent lifting, excess vibration, and unnatural posture when working are one of the types of ergonomic hazards. Overload and human force may have a negative impact on a worker's health. Last but not least is safety hazards. Safety hazards can impact any employee, but those who work with machinery in a production plant or on a building site are more likely to be affected.
Assalamualaikum. My name is Nufara Shamimi binti Anwar, and I am going to proceed with the hazard and operability analysis, or also known as HAZOP. First and foremost, there are three different guide words that were used in this analysis, which are no, none, not, lower, less, more, higher, greater. For example, no flow of feed into the reactor, the pressure is lower than the operating condition, or the temperature is higher than the set point. Moving on to the main point, we have conducted the HAZOP analysis on 5 different study nodes. The first one is feed pipeline, which is used to transport toluene into toluene feed drum. And the process parameter that we evaluated was flow with the guide words no. This can be possibly caused by blocked pipeline, no controller and control valve, and pipe rupture, which will result in no feed flows into the reactor and no reactions will occur. The actions required for this problem is by installing a fail open or fail close control valve and installing flow controller and flow transmitter. The second study note is reactor where hydrogen reacts with toluene to produce benzene and methane. Two process parameters were evaluated for reactor, which are flow and temperature. So for flow parameter, three guidewords were used, which are no flow, low flow, and high flow. The possible cause of no flow are blocked pipeline, pipe leak or rupture, and pump or compressor failure. This can cause no feed flow into the reactor, no reaction occurs, and no product flow. Two actions required for this are install flushing system to unplug pipeline, install flow controller and transmitter. Whereas for low flow, the possible causes are partial plug pipeline, pipe leak or rupture, pump or compressor failure, hence resulting in reducing the reaction and reducing the product flow. Two actions required are install flushing system to unplug pipeline and install flow controller and transmitter. And lastly, for high flow, the possible causes are FIC controller fails and open the valve, FCV fails open. It can result in consequences such as increasing the reaction heat and resulting in low product flow. There are three actions that can be done, which are install independent flow controller and transmitter, install high flow alarm to alert the operator, as well as troubleshoot the upstream. The third study note is feed heater, which is used to preheat the mixture of toluene and benzene at 90 degrees Celsius before being fed to T101. There are two process parameters that were evaluated, which are flow and temperature. So for temperature parameter, guide words used are low temperature and high temperature. Low temperature can be possibly caused by flame out, which results in cold shot to R101 quenching reaction, and the actions required is include automatic flame detection with reignition cycle. While for high temperature, the possible causes are sudden reduction in stream 6 flow rate and increase in temperature of stream 4. It can result in consequences such as reactor overheats and flame becomes erratic. Two actions required are consider an interlock on fuel gas flow and robust demister design. That's all from me. Now I will pass this presentation to Siti Hazwani to further explain on the other two study notes.
Hi, I am Sita Hazwani. So for now, I'll continue this presentation. So let's move on to distillation column. Distillation column operated at temperature of 112 degrees Celsius and pressure of 2.5 bar, where the mixture of toluene and benzene is being fed into it. The process parameter consists of two, which are flow and level. Level has two guide words, which are low and high. So first, when there's a low level in distillation column, it will cause pipe partially clogged and pipe leakage, where the valve will be closed and backflow of material will happen. So in order to prevent the low level in distillation column, we need to locate a low level alarm, place a valve, and check the maintenance procedure and schedule. So next, high level in distillation column will generate output blockage, where the reflux drum become overpressure and condensed liquid flows back to distillation. So action required is we need to install a high level alarm and inspect the maintenance procedure and schedule. So the last one is product cooler, where the other part of the liquid is cooled to a temperature of 38 degrees Celsius and pressure of 2.5 bar. Product cooler consists of one process parameter only with three guide words, which are no, low, and high. So when there's no flow in product cooler, it will produce failure of inlet cooling water valve to open, where the temperature will not reach the set point. So what we need to do, we need to install temperature indicator and install a high temperature alarm. So when there's a low flow in product cooler, it will create pipe leakage and blockage. So the process fluid temperature will become too low or it will does not change. So the action required is we need to install a flow indicator and controller and also install a high temperature alarm. So last but not least, when there is high flow in product cooler, it will generate failure of inlet cooling water valve to close, where the outlet product temperature will become too low and process fluid temperature will decreases. So we need to install temperature indicator and install a low temperature alarm. Now we will proceed with hazard identification, risk assessment, and risk control, which is known as HIRAC. So this is our HIRAC form. So first is loading of raw material and catalyst. The risk rating is calculated to be 15. So we recommend to label and prepare a safety data sheet and train workers to handle chemical appropriately as the control measure. So the second one is cleaning of reactor and benzene column. The risk rating is 27, which is the most highest one. So we propose to use suitable PPE and provide training to workers. And the third one is storage of finished product. The risk rating is 16. So we need to store the finished product at well-ventilated place, and maintenance of the piping system should be done regularly. So the next one is maintenance of instrument. So the risk rating is 12. We should provide adequate electrical and wiring system training to the employee. So the last one is working long hours, which the risk rating is 10. So we need to set a limit of working hours or improve shift pattern. So that's all from me. I will pass this presentation to Nur Hidayah.
My name is Nur Hidayah binti Rozi, and today I will present the improved PNID and also the plan layout. So for the first one, at the feed pipeline, we have decided to install a flow indicator and measure and controller to measure and control the pipeline, the feed into the process. Second, we have decided at the heater, we have decided to install a flow meter fuel gas and also alarm to measure the fuel gas and the heater for the safety purpose. And the second one, we have decided to install a temperature indicator controller to control the temperature inside the heater. And the third one, we have decided to install a flame detector to detect the presence of the flame and also fire if any emergency happens. At the reactor, because of this process is exothermic process, we have decided to install a cooling jacket to prevent overheating happening. And the last one, and second one, flow controller to control the flow. And the last one, temperature alarm low and temperature alarm high give an alert and also warning of the temperature at the control room if anything happen at the equipment. Same as the distillation column and also a cooler, we install alarm low and alarm high to give an alarm if any emergency happen at the particular equipment. Move on to the plan layout. At the plan layout, as you can see here at the center of the plan is manufacturing plan, and also near manufacturing plan we have a control plan, lab, and also engineering workshop in order to enable to running smoothly the process. And then we have a canteen and a medical center far from the manufacturing plant to avoid the exposure of the hazardous chemicals. And then, as you can see here, we have three assembly point to assemble and also to do rehearsal. If any emergency happens, such as explosion or a flooding, um, explosion or massive flooding happen. As you can see, the assembly point is located at the main gate, the first one and the third one, whereas the assembly point second is near the medical center. And also we have a fire station at our plant production. Conclusion, all production have to plan the hazard, hierarchy, and also PNID improvement in order to increase the measurement safety measure, and also it helps to identify possible risk and hazard in the production. Regular review and inspection is a must in order to increase the safety of workers, society, environment, and also its cost saving as well. That's all from us. Thank you.